Hi, guys. It's me, Mr. Bertoch, your incredibly handsome science teacher. And in this video, we're going to learn about one of my favorite topics, which are minerals, gems, and rocks. So we're going to talk about, in this video, minerals and gems and rocks, which are among my most favoriteest of topics. I like science in general, right? And if I had to pick a topic that is my favorite, it would be astronomy. But right behind that, and closely related for that matter, is geology. It's just fascinating to me, anyway. It's interesting. I mean, what child doesn't love to collect rocks? That's, I think, almost a universal experience. And I guess I just never grew out of it. And I've got a little rock collection. It's not a big rock collection, but in it I have things like uh, dinosaur bones and meteorites and Bixbyte, which is a really rare gem. And and it's just neat to see how the Earth, which formed 4.54 billion years ago ish, that's what scientists believe, has evolved into this complex and diverse planet. When it first formed 4.5 billion years ago, it was a ball of magma, and it was mostly the same. It was just magma everywhere. And as it hardened, that magma has diversified. It's formed so many, in fact, thousands and thousands of kinds of minerals and gems and rocks that are very different from each other. Obviously, a diamond, which is a pure and clear gemstone made out of carbon, is very, very different than like granite, which is a gray, speckled, because it's got little crystals in it, of quartz and other stuff. But it's a gray rock. Well, how did that happen? How did the Earth evolve like that? How did it just create so many different types of rocks, from sandstone to andesite to basalt to so many other kinds of rocks? Where did all of this come from? And that's what learning about minerals and gems and rocks helps us to understand. It's a starting place. In later videos, we're going to learn about more about rocks and the classifications of rocks and how to identify rocks, all of which are very interesting if you want to impress people when they find a rock on the ground. That's something my kids have always loved to do, is to find a rock and bring it to me and say, "Dad, what kind of rock is this?" And to be able to find out. And we're going to talk a little bit about, in this video, actually, although we're just going to touch on it in this video, how to start to understand how to identify rocks. But let's start with minerals. Okay. Mineral is a word that I am sure you have heard, because we use it a lot in nutrition, for one thing. We talk about getting enough minerals in your diet. Well, what are minerals? I'm going to give you a definition, and it might sound a little bit fuzzy at first, but bear with me because we'll bring it into focus for you. Okay. So a mineral is an inorganic substance that forms naturally and that has a regular and repeating pattern, a regular, predictable pattern. Well, what in the heck does that mean? Because those are some big sciencey words, right? Organic. What does inorganic mean? What does organic mean? A mineral has to be inorganic. It can't be organic. You've probably heard the word organic. We use that in nutrition as well. But what does it refer to? Okay, inorganic just means non-living, essentially. Organic means living, more or less. So organic substances like carbohydrates and lipids, which are fats, carbohydrates or sugars, or proteins or amino acids or whatever, these are all things having to do with life. Inorganic are like salt and, well, there's a lot of them, but are having to do with not having to do with life, just non-living. So a mineral has to be inorganic in order to count as a mineral. That means it is non-living. Okay, the second thing is that it has to occur naturally on the earth. So we can create as humans, and we do all the time, in factories. Chemists have come up with a whole bunch of compounds that are inorganic, and we use them for all kinds of things. I mean, we make glue and plastic and, all kinds of things, skeletons that wear Slytherin ties and whatever, that are made using inorganic material, non-living, but they're made by humans, so they don't count. A mineral is something that develops naturally on the earth without the help of humans. And so it's been here for billions of years since the beginning and has formed over time. Well, there are literally thousands of these different kinds of materials that form on the earth. As the earth cooled and the earth's crust solidified and rain fell and materials eroded away and were washed around and different things happened, well, processes occurred that began to formulate rock into different types of substances or minerals, and using inorganic materials and forming naturally. And then the third part of this definition, to qualify as a mineral, is what? It has to have a regular and predictable pattern. And by that, we mean the molecules themselves, the atoms. Okay, so they form a regular, repeating, predictable pattern. So when the molecules and atoms stick together in a mineral, they're going to form a regular, repeating pattern, which results in them having a very specific look and a very specific way that they are. Their characteristics and traits are predictable. So, for example, if I find salt, it looks like salt, right? No matter where I find it, it's going to be kind of white, clear, and it's going to taste salty. And it's going to dissolve in water. It's going to have the same characteristics no matter where I find it. Salt is a mineral, by the way. Or if I find copper, right? Copper is very different than salt, and copper tends to follow the same characteristics no matter where it is. So there's our definition of a mineral. Again, it's inorganic. It occurs naturally without the help of the we humans, and it has a regular and predictable pattern when the atoms and molecules stick together. Okay. So throughout time, thousands of these minerals have occurred. And you might hear the word mineral deposit because they tend to kind of be in similar places. Like you don't just find typically one little piece of whatever mineral, right? One molecule of it by itself. You tend to find deposits. You tend to find, to use a word from cycles, you tend to find reservoirs of these things, of the material, that the mineral. So you'll find a salt deposit. Where I grew up in Utah, I grew up just a few miles from the Great Salt Lake, and there's a lot of salt. Well, the Great Salt Lake, there's a lot of salt there that different processes, natural processes, have first created and then deposited together in the same place. So as a handsome expert of minerals, or even the ugly ones, whatever, you have to be able to identify different minerals And scientists use the characteristics, the predictable traits of minerals to help them identify them. We will talk about these in a lot more detail in another video, but just so you know, some of them are things like cleavage, which refers to how a mineral breaks. So if I find a deposit of a mineral, and remember, they've stuck together in this repeating pattern, so they've kind of made a rock out of the mineral. If I smack it with a hammer, because I don't know, I'm angry for some reason and I'm smacking the mountain with a hammer, it's going to break in a predictable way based on the type of mineral it is. So some of them break off in flakes, like flat flakes, right? Or they might break with a certain jagged type of pattern. And so we can, if we know what the cleavage is supposed to be for a type of mineral, and and we hit the rock and it breaks that way, we can say, okay, this is probably whatever the type of mineral I think it is, because it breaks the right way, it cleaves the right way. Another test we use is the luster, which refers to how light shines off of the mineral. Or we can look at streak, which is, if you probably noticed this, if you take a rock and you write on the concrete with it. Have you ever done that? Have you ever taken a rock and then used it like like chalk on cement? You can actually write with the rock. That's called streak. And each mineral has a predictable color and way that it will streak. We also look at the hardness. So these are some of the characteristics. There's others too that we look at when we are identifying a mineral. Well, let's talk about gems now. Gems are, because remember, what do minerals do? The third part of the definition, do you remember? What, pray tell? In order to be a mineral, it has to have a regular and repeating pattern, right? And that regular repeating pattern has the effect that it can produce crystals, because that's what crystals are. They're a regular repeating set of molecules. That's why they end up being so pretty. And so the crystallization of minerals creates gems. Examples are like quartz or amethyst, which is mostly quartz. Or we already mentioned diamonds, olivine, emeralds, rubies, right? There's a lot of naturally occurring gemstones, gems, that form from minerals. So a gem is a mineral, sometimes a few minerals, or a mineral with something else mixed in it, that results in a specific precious gemstone. Okay. And then finally, the third thing that forms naturally is rocks. And if you're SpongeBob, you say, it's not a boulder, it's a rock. And I can't talk about rocks without mentioning that very important fact. An episode of SpongeBob where he delivers pizzas. But anyway, what's a rock? Do you know what a rock is? Yeah, I think you probably do, right? You've seen rocks. You don't really need me to define what a rock is, except to say that a rock is also made out of minerals, and often also made out of tiny little gems in there, although you might not see them, but they're there if you look under a microscope. It's just a conglomeration of minerals and gems all stuck together and mixed up. Okay, there is no predictable repeating pattern in a rock. A gem has a predictable repeating pattern. The way the mineral sticks together, a rock is just all mixed up and stuck together. A great example of that is granite. Granite is actually kind of a pretty rock. And if you look closely at it, it's this gray rock. You can find granite in a lot of places. And it's got speckles in it. Well, what in the heck are the speckles? They're little gems. They're little quartz gems. Actually, another example is sand, by the way. Sand's not a rock. I should have mentioned sand when I was talking about gems. What is sand at the beach? If you pick up a little a nugget's not the right word. What do you call sand? A little grain. Oh, yeah, there you go. A grain of sand, not a nugget of sand. If you find a nugget of sand, that's probably not sand. It's probably something else. But if you pick up a grain of sand and look at it, you're gonna see a little tiny quartz crystal, probably, because that's what sand pretty much is. So, because quartz lasts a long time. Yeah. So minerals are inorganic substances that that occur naturally and have a regular and repeating pattern. That regular and repeating pattern can lead to the formation of gems. And rocks do not have a regular repeating pattern. They're just a bunch of stuck together minerals and gems. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos and they're much more targeted. And those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.